Hello everyone, a very good evening to all of you. Welcome to Jatadhara Educational Technology. I am Tripti. Let's start with our NAVODAYA coaching class for maths. Okay, so children, I'll share my screen now. Today we are going to know about LCM and HCF by prime factorization method. Okay, allow me a moment. I'll quickly share my screen. Uh, One thing I want to tell you, dear children, that we are live on YouTube. Please make full use of these live sessions. These are going to be very helpful for you because you can chat, you can make use of the live chat box to ask your queries if you have any. You can also, just answer side by side. Okay. You can give answer to the questions in the live chat, and I am constantly keeping an eye on the chat box to see what are your answers. All right, so let's get started. I hope my screen is visible to all. Okay, perfect. Children, be ready. Also share this video with your friends so that they can also take full benefit from these sessions. Share this video with your friends, and I'm waiting for you in the live chat. Okay, perfect. So let's start with LCM and HCF by prime factorization method. Let's find out more about LCM and HCF by prime factorization method. You know, we were doing this LCM and HCF only. So let's know more about it today. Find the LCM and HCF of 6 and 8 by prime factorization method. So here, prime factorization of 6 can be done as 2 times 3. Okay. And prime factorization of 8 can be done as 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Prime factorization of 6 is 2 times 3. Okay. Prime factorization is when you, write the numbers in the form of prime factors. Okay. LCM is the product of prime factors either in 6 or in 8. Let's see. What is the LCM here? 2 times, wait a second. Yeah, LCM is 2 times 2 times 2 and 3. What we have done here is we have done the product of 2 times 2 times 2, which is the product of prime factors either in 6 or in 8. Or you can simply say we have made a group like this, 2 here. Then for the numbers that I cannot make the group is 2, 2, and 3. Okay. Or you can say I will take the maximum number, like 2 is there and 3 is there. 2 is occurring for maximum 3 times. So I have written 1, 2, 3 times, and there is 1, 3. Okay. So 2 times 2 times 2 times 3. So LCM is 24. That means least common multiple is 24. Yeah. And HCF is a product of prime factors present in both 6 or 8. How? How will it go? Wait, I'll just remove it. Yeah. It will go like just you are able to make only one pair. It's 2. HCF is 2. LCM is product of prime factors either in 6 or in 8. And HCF is product of prime factors present in both 6 or in 8. Okay, so basically you have to make a group. That's what you can say. Right? Now, let's do the next one over here. The next question is prime factorization of 4 and 10. So if I talk about the prime factors of 4, the prime factorization of 4, I can do it like 2 times 2, and 10 can be done as 2 times 5. Okay, I'll write here LCM and here HCF. So As you have seen in the last question, it says that LCM is product of prime factors either in 6 or in 8, and HCF is product of prime factors present in both 6 or 8. Okay, so max either in 4 or in 10, so it's like 2 times 2 times 5. One pair, and then the remaining ones are 2 and 5. For HCF, it's just one pair, so I'll take 2. For LCM is 2 times 2 is 4, 4 times 5 is 20. This is the LCM and this is the HCF. Okay. So HCF is 2 and LCM is 20. Yeah. Let's do the next one. 6 and 10. 6 and 10. Okay. So here it's 2 times 3 and this is 2 times 5. Okay. LCM here, HCF here. Okay. So LCM is 2 either in 6 or 10, right? So 2 here and 3 and 5. And for HCF, it's just one pair, so I'll take 2. So HCF is 2, LCM is 2 times 3 is 6, 6 times 5 is 30. 30 is the LCM. Least common multiple is 30. Highest common factor is 2. Okay? Okay, let's go to the next one. Finding HCF and LCM of 8 and 10. 8 and 10. So I'll write 8 as 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. And 10 is 2 times 5. Okay. Now LCM is here. 2 times 2 times 2 times 5. And I can make only one pair, which is present in both. So it's 2. Okay. LCM is 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. Okay. LCM is 40. HCF is 2. Yeah. Let's do the next one over here. Do this. Okay, so for 6 is 2 times 3. 3 for 9 is 3 times 3. Okay, LCM is 3 times 3 times 2 and HCF is 3. Okay, LCM is 3 times 3 is 9. 9 times 2 is 18. 18 is the LCM. Okay, and HCF is 3. I hope you got the same answer. Let's do the next one. HCF and LCM of 6 and 12. 6 and 12. Okay, so here 6 can be written as 2 times 3 and 12 can be written as 2 times 2 times 3, which is like 2 times 2 is 4, 4 times 3 is 12. Okay, so LCM is 2 times, here I can make a pair of 3 times 2. Okay, and HCF is 2 times 3. So 2 times 2 is 4, 4 times 3 is 12, 12 is the LCM, and HCF is 2 times 3, which is 6, right? Next one, 6 and 15. HCF and LCM of 6 and 15. Okay, so 6, 15, 2 times 3 is 6, 3 times 5 is 15. LCM here, HCF here. Okay, here it's going to be like LCM is, I can just make a pair of 3 and the other numbers are 2 and 5 and HCF is only 3. So 2 5s are 10, 10 3s are 30. 30 is the least common multiple and HCF is 3. Okay. Now, let's study the relationship between LCM and HCF of two numbers with their product. Over here, there is a relationship between two numbers and their LCM and HCF. See the numbers 4 and 10. Prime factorization of 4 is 2 times 2 and prime factorization of 10 is 2 times 5. LCM is product of prime factors either in 4 or in 10. You know that. We have done this. And here, like LCM is 2 times 2 times 5, which is 20. And if I talk about HCF, which is a product of prime factors present in both 4 and 8. So HCF is 2, right? Here, there is a relation as I already mentioned. The relation is LCM times the HCF is equal to the product of two numbers. LCM times HCF is 20 times 2, which is equal to 40. and that should be equal to the two numbers for which you have taken out the HCF and LCM. 40 here, 40 here. Okay, so like this, right? Product of prime fact, like LCM and HCF is equal to product of numbers. Now let's check this for other numbers as well. So 6 and 8, find the HCF and LCM, then the relation. Okay, so here LCM is 24, HCF is 2. I told you the relationship between two numbers. The relationship between two numbers is HCF times the LCM is equal to the product of two numbers. Okay, so HCF, what is the HCF? 2. LCM is 24. It should be equal to the product of two numbers like 6 and 8. 2 times 24 is 48 and 6 times 8 is 48. So both are equal. Yeah, relationship proved. HCF times LCM is equal to the product of two numbers. Hence proved. Right? Let's go to the next one. We'll see this. The same way this has been done, you can check. Yeah. Right? So that's how we have to do this. Let's practice more of these questions. Okay. Over here. Let's check for other numbers 6 and 20. Come on, children, I'm giving you time to do this. 6 and 20. Okay. So 6 is 2 times 3 and 20 is 2 times 4. Wait. Sorry, wait. Okay. So 2 times 2 times 5. Because 2 times 2 is 4. 4 times 5 is 20. Okay. Now LCM is maximum number of times that 2 is occurring is 2. Okay. Times 3 times 5. And HCF is just 2. So let's see what is the LCM. 2 times 2 is 4, right? 3 times 5 is 15. 2 times 2 is 4. 3 times 5 is 15. 15 times 4 is 60 here and 2 here. Okay. So LCM is 60, HCF is 2, and the product of two numbers is 6 times 20. That is 120, and here 120. Relation proved. Yeah. Let's do the next question, dear children. Over here, 15 and 20. 15 and 20. Be quick. So here, 15 can be written as 3 times 5. Yeah. And here, 20 can be written as 2 times 5. Right? Second. Yeah. Okay. So LCM can be written as, you can say that the LCM is 5 times 2 times 2 times 3. 5 times 2 is 10, 2 times 3 is 6. 6 tens are 60. 60 is the LCM. And HCF is 5. Okay. Now, LCM 60 times HCF 5. 60 times 5 is equal to the product of two numbers. 15 times 20. Okay. So 300 here. 15 times 20 is again 300. Hence proved. Yeah. This is how you can check the relationship between the two numbers. Right? Now, children, separately, we will work on the, relationship between the numbers. Wait. Okay. Here we go. Relationship between the two numbers and their LCM and HCF. Okay, we are going to work on this now. LCM and HCF is equal to the product of two numbers. We understood that thing. Product of two numbers is 24. Their HCF is 2. Find the LCM. So the question can come in this form also. Okay. Here, product of two numbers, is 24, right? LCM times HCF also, is 24 because product of two numbers is equal to LCM and their HCF, right? So here, LCM times HCF is equal to the product of two numbers. LCM we don't know, but HCF we know, that is 2, okay? Which we know is 24, okay? Now here, LCM, we can clearly see that 24, okay, how we'll do it? LCM is equal to 24 divided by 2, which is equal to 12. Okay, that's how you can do this, right? Let's go to the next question now. Over here, we'll see that product of two numbers is 28. Their HCF is 1, find their LCM. Do it. So this is the equation that we see. Here, if we see, we can say that LCM is equal to 28 only. Okay, LCM is 28. Product of two numbers is 28. HCF times LCM is 1 time LCM, which is 28. Okay, because 28 divided by 1 is 28. Right. Next one, product of two numbers is 50 and their HCF is 5. Find their LCM. Okay, so here product of two numbers is 50, HCF is 5, LCM we don't know. So 50 divided by 5 is will. That's how we will get the LCM. So 50 divided by 5 is 10. 10 is the LCM. Okay. 10 is the LCM. Yeah. Let's go to the next question now. So here the next question is product of two numbers is 120 and their HCF is 2. Find the LCM. Okay. So here product of two numbers is 120. HCF is 2. LCM we don't know. Okay. So 120 divided by 2 is LCM. LCM is 60. LCM is 60. Yeah? LCM is 60. Let's do the next question now. Product of two numbers is 100. Their HCF is fine. Find their LCM. Okay, so it's 100 is equal to HCF is 5, LCM we have to find. So 100 divided by 5 is the LCM. So it is equal to 20. 20 is the LCM. Yeah. Let's move on to the next question. Can LCM of two numbers be greater than the HCF? Think and tell. Can LCM of two numbers be greater than the HCF? Yes, it can be. Okay. Can HCF of two numbers be greater than their LCM? Think. No, that is not possible. So, HCF of two numbers cannot be greater than the LCM. So, children, with this, we are done with our today's session. Yeah. Thank you so much for joining the class and paying attention. I hope you understood like everything, right? And if you have any doubts, anything, please let me know in the live chat, right? And as I always say, please keep practicing because practice will make you perfect, right? So yeah, that's all. Thanks once again for joining. Bye-bye. Have a good day. I'll see you again super soon. By the time, take care and have fun. Have a lovely day ahead, everyone. Bye-bye.